From the 2022 statistical data, 99% of the total coffee bean production in Indonesia originates from people plantation. This presents a significant business opportunity, emphasizing the potential to improve the welfare of the farmer and establish a sustainable coffee supply chain. Simultaneously, the increasing trend in coffee consumption and a growing coffee shop industry have elevated the demand for green coffee beans. However, this does not rule out the possibility of challenges and issues. According to the news article on the Indonesian People Consultative Assembly, Hamid Nur Yassin, a member of the DPRI Commission for Review, that with the rising global coffee consumption, foreign exporters have raised concern about the quality of coffee by implementing product certification. Local coffee farmers object to such assessment as they tend to undervalue the quality of their coffee. This is because small and medium-sized businesses still lack processing technology. Therefore, extensive knowledge is needed to maintain the quality of green coffee bean supplier and the grading process of green coffee bean before the roasting stage for coffee shop operators. Our team chose to address this theme because agribusiness can play a significant role in Indonesia's agricultural sector. One of these is the coffee bean farming sector, facing challenges and issues related to quality and market fulfillment. Additionally, leveraging digital technology can empower small-scale farmers by providing access to market information and training, ultimately enhancing their productivity and profitability. Based on the issue we have identified, we offer two solutions to address the two existing problems, focusing on production and marketing. We propose a solution that can assist coffee farmers, which come in the form of an application assess and maintain the quality of coffee beans to meet the specific quality standard. Moreover, the Blue application is expected to serve as a platform to connect stakeholders involved in the supply of coffee beans, namely farmers, with those in need of coffee beans.
Existing results. Based on our research on existing application, the majority of them focus on developing e-commerce application for coffee beans commodities, as well as educational or guidance related to the coffee making process, which is included like gradings, roasting, and brewing. When evaluating the percentage of similarity between our application and others, it can be concluded around 10% of the features have similarities, especially concerning information and guidance in the coffee making process. On our application, we are focusing to checking the quality of green bean, and I will provide the community to share the experience to around the world, and this is existing results of our application.
To train a machine learning model to recognize image of good and defective coffee beans, we use two datasets, namely good and defective coffee bean datasets. We combine the dataset on Kaggle and the result of taking off on picture. We use Google Colab as a platform to code and train machine learning using TensorFlow. First, we download the dataset from the drive, then we perform augmentation to improve the accuracy of the model. After that, we create our training model based on the CNN architecture we compile. After training the model and getting results with good accuracy, we save it in form of .h5 file. As can be seen in the figure, the best accuracy in our model is located in HPOTS 91 with best training accuracy around 91% and best validation accuracy around 91%. The CNN architecture that we use is shown in the picture. To reproducibility the model and use API, you can do the following step below. Call or download in this link, open the folder, train my modeling, and there is the file training model. You can test or develop the model with Jupyter Notebook or Google Colab. To test the model using API, first open Visual Studio Code and open the project. Open the terminal in Visual Studio Code after you open the project. Upgrade pip install your requirements, the text with pip install and requirement text. Then run Python app.py. For more information, you can see on our GitHub with this link.
Now, I will explain the implementation that we did from the backend side of our application. First, you can see we designed this infrastructure as shown in the picture. We use three services from the Google Cloud Platform, namely Cloud Storage, as a medium for storing and managing all user image. This service helps to manage image files that enter our application. Then, Compute Engine as MySQL server. We use this service because we can create a server for all MySQL database at a lower cost. And finally, Cloud Run as the main server to run our API. This service is more efficient for managing our API, saving in terms of cost and time. For the API itself, we made it with two different frameworks, namely Node.js for the main API and Flask for the machine learning model API. For the service that we used earlier, you can see it here. We managed to create and run -3 service well, so that our API can run well according to the design we made earlier. Then, for our API result, you can see some endpoint that you can try using our domain. To try all the endpoint we made, you can see the API documentation at the URL. Or you can visit our GitHub. Last from me, this is how to use API for basic uses that do not require GCP service. You can follow the step that. And you can see the full step using this project and more information in our GitHub.
I will introduce the main feature and community feature in the Greenbean application. For the first login feature, the login feature allows users to access their account securely and easily. Users can log into the Greenbean app using the credential they have previously registered, giving direct access to available feature. For number 2, feature register. The register feature allows new users to create an account on the Greenbean app. With registration, users can create their personal profile, save preference, and well as get full access to the feature provided by this application. With this login and registration feature, Greenbean provides a personalized experience to users, allowing them to explore and use the feature provided with optimal ease and security. So, for home feature, our homepage feature allows you browse high quality coffee bean sample as well as get the best recommendation from our perspective. And scanning or scanner feature. Our main feature is a scanner that can access the viability of the coffee beans. This distinguish between good quality coffee and those with defect. And for the last, community feature. Finally, the community feature aims to provide access to reviews from the other users about coffee beans they review. Here you can upload the result of the processing of coffee bean that you do, as well as provide comments or opinions about the coffee beans that you have enjoyed. This helps us find coffee beans that match our preference. With this feature, Greenbean is here to provide an immersive experience for coffee lovers, from discovering quality coffee beans to sharing knowledge in an active community.
Plan a local deployment on your project. For local deployment, we have planned for 6 months starting from January to June. In January to February, we will update the community feature to be more user-friendly, add share, save, and chat features, and update the Greenbean coffee quality feature for live scanning and massive scanning. In March, we will conduct more research on Greenbean coffee grading and roasting standards, and combine the Greenbean and roasted bean grading features. In April, we will add e-commerce features for buying and selling green coffee and create a website platform for user and admin controls. Both tasks will start in March and are planned to end in April. In May, we will engage with potential users and stakeholders and launch a marketing campaign to create awareness. Finally, in June, we will test the app, prepare for the launch, and also launch the app on the Google Play Store.
Our advantage: coffee bean defect detection, coffee education for the community, platform for sharing coffee experience and finding suppliers. SWOT: strengths: facilitating grading, mobile version teach, coffee quality info. Weaknesses: unfriendly interface for farmers, reliance on internet in rural areas. Opportunities: growing interest, global expansion, unique market position. Threats: similar computer version competition. Marketing strategy: education farmers on enhancing coffee quality and prices. Direct marketing, brochures, business cards, product demos. Utilize social media for brand awareness and community engagement. Seek partnership in the coffee industry and state or private plantation. And you can see our budgeting summary in the following table.